This lesson is on climate classification. All right, climatology is the study of Earth's climate and factors affecting past, present, and future climatic changes. So it's important to point out the difference between weather and climate. When we're talking about weather, we're talking about short term patterns. We're talking about what's happening today, tomorrow, the coming few weeks, maybe the next month or so. But with climate, we're talking about long term weather patterns. We're talking about the weather patterns for a given area over around 30 years or so, 30 years or more, we should say. One of the main things that affects climate is latitude. How far north or how far south a location is on the earth, or otherwise, in another way to put it, we could say, how close is a location to the equator or the poles, because that's going to matter. That's going to greatly affect that location's climate, because areas near the equator get more direct heating from sunlight than do areas closer to the poles. So this causes some areas to be colder and some areas to be warmer just based on that one factor alone. Climate zones are based on long-term temperature and precipitation mostly. Sometimes the type of vegetation in a location comes into play, but for the most part, when we talk about climate, the main two things we're going to talk about are long-term temperature and precipitation trends. Also, topography can have effects on climate, meaning the kind of landforms you have in a location can have certain effects on climate. For example, places that are very high in elevation can have a much different climate than lower lying areas all around it. And we'll talk about that later on. We've pointed out before about the differential heating of water and land. Water heats up and cools down slower than land does. And also, we have the ocean currents, and this helps coastal areas have more moderate climates in general. So, areas closer to the oceans are going to be a little bit more moderate than areas that are far inland. Furthermore, the differential heating of water and the circulation of our ocean currents, like we said during the ocean currents lesson, if it weren't for those, the hotter parts of the earth would be much hotter, more extremely hotter than they are now, and the colder parts would be much more cold, extremely cold than they are now. So it's very important that we understand the flow of the ocean currents helps make things more moderate. Temperatures in the troposphere decrease with altitude. We've talked about that before. The troposphere is the layer of Earth's atmosphere that is closest to Earth's surface. That's the layer we reside in and where our weather events happen. And the higher you go up in the troposphere, the colder it is. And that's what I meant to say about these mountainous regions are cooler than regions around them that are closer to sea level for this very reason. And we also have an effect called orographic lifting, and this can cause very dry areas on one side of a mountain and very or we should say a mountain range, and very moist and green areas on the other side. And the reason why is that these clouds have to rise, these air masses and clouds have to raise up very high to get over the peaks of these mountain ranges. And we talked before in our lesson about cloud formation, how the higher these air masses and these clouds go, the colder they get, the more they contract, the more dense they become, and their ability to hold moisture is decreased. Their absolute humidity is decreased. So it's like these clouds are having all the water squeezed out of them going up one side of a mountain range, and then as they come down the other side, they come down much drier than they were before. So this cold, dry, descending air comes down. So this is called orographic lifting, and this creates what they call a rain shadow on this side of the mountain. So this typically happens, on in North America as the weather kind of moves from west to east. and weather has to go over these mountain ranges, it normally leaves kind of a, like I said, a moist green area on one side of the mountain range, and then the other side you get a very dry, cool area on the other side. All right, a climatograph. These show the monthly average temperature and precipitation for a particular area. Here you see you have temperature on this side, you have precipitation here, and then you have months here. And this is showing, the temperatures and the amounts of rainfall over the course of a year. So these are used to track climate patterns, and you look at these for, like I said, 30 years or more, and that gives you the general idea of what an area's climate is like. So scientists studying climate, they keep up with all this information, and that way they can notice if any of the trends seem to shift or change for any reason. And climate shifts are definitely a real thing, and some of them are definitely caused by natural things, and then others really are caused by human activity. And it's really important to know what is what, and keep track of the past climate trends, so that when a new trend emerges, that this is something new or something different than what that area is used to. All right, let's talk about climate classifications. We're going to talk about the Köppen classification system. Now it looks like it says Köppen, but it's got an umlaut over the O there. That letter in German is called a O umlaut, and it kind of makes the ER sound. In English, we never really say it quite correctly, but it's perfectly acceptable as an English speaker to call this the Köppen classification system. All right, this bases climates on vegetation types as well as average monthly precipitation and temperature. So there are other classification systems for climate. Most of those just go by precipitation and temperature only, but the Köppen system also considers what type of vegetation exists in that area. You may also see it spelled like this, with Koeppen, still pronounced the same way. I know there's no R there, and that's strange to us as native English speakers, but that's the way it's pronounced, as Köppen. All right, let's talk about our tropical climates first. So tropical climates have constant high temperatures. Some have up to 236 inches of rain each year. So we're talking about areas that are constantly warm or hot and have lots and lots of rainfall. Tropical rainforests have tropical vegetation as well. So when we're talking about these climates, we're talking about areas near the equator, kind of in the tropics or closer to the equator. These climates are heavily affected by those maritime tropical air masses that form over water and close enough to the equator that they are warm and moist. So examples of these areas would be Brazil, Indonesia, the Congo, which was formerly referred to as Zaire. You can see here the blue areas on the map represent our tropical areas. So you can see parts of Mexico, and then pretty much all of Central America, many of the Caribbean islands, the northern part of South America, the middle part of Africa, and then lots of South Asia, including Indonesia, Malaysia, the Philippines, even parts of northern Australia as well. So you can see the equator runs about right here across the map. It's not pictured here, but it runs about right through there. So you can see these tropical climates are centered on the equator. All right, moving on to arid climates. Arid is like another word for dry. Okay, so the arid, dry climates, they cover 30% of Earth's land. It's the largest climate zone. These are mainly influenced by continental tropical air masses. These are the warm, dry air masses. These air masses form over land, so they're typically dry, and they form close to the equator, so they're typically hot. In these arid climates, there is usually little vegetation. In some parts of these arid climates, there is none to be found at all. Very high temperatures for the most part, but low precipitation. So very dry, not a lot of rain, but pretty constant high temperatures. Now, one thing about deserts that's often overlooked is that because there are no trees, because there's not a lot of cloud cover in these arid climates, there's also nothing much to hold heat in at night. So at nighttime, it can be very cold in the desert. So we're talking about a lot of hot days and really cold nights, and as you know, cold air cannot hold much moisture either. So we're talking about something else that really kind of isn't thought of much, but contributes to the dryness of these areas. So examples of arid climates are the Sahara Desert in northern Africa, the Mojave Desert in the United States out west, the Gobi Desert in Mongolia and China, as well as other places. Okay, so all the brown areas on the map here are arid climates, and you can see these arid climates cover a good deal of the Earth's land surface. So you see here in the western United States, down into Mexico, we have a lot of arid climate areas. The west coast of South America here has a lot of them. Parts of South Africa here, or Southern Africa, I should say. Northern Africa, huge, the biggest arid climate zone all across North Africa and into the Middle East. And then we see big swaths of Asia covered in these arid climates, and then a very significant portion of Australia as well. All right, on to temperate climates. This is what us living in North Carolina are mostly kind of used to. And now I know that it gets quite cold here in the winter and quite hot here in the summer, but our climate zone is considered to be quite temperate or moderate. So these climates generally do not have huge temperature difference between their cold months and warm months. Now I know you're already thinking, well, you just said that it can get quite cold here, quite warm here, but it's all relative. When we start talking about these climate zones that are far inland in the middle of large continents, yeah, our temperature differences between the cold months and the warm months, even though it might seem kind of drastic to us at times, it's nothing compared to, say, the middle of Siberia or the middle of Canada. All right, so temperate climates, the winters are generally a little bit warmer and the summers are generally cooler than other places. So examples, like I said, right here where we are in the southeastern United States, Italy is an example of a temperate climate. Parts of India, and you can see here, this map's a little bit different. It includes other climate zones, but all of them with this yellowish color here are considered to be the mild climate zone. So you can see here a big part of China and other parts of Asia, part of India here. Even some parts of the Middle East are considered to be this, especially here in Turkey along the and the Levant here, like along the Mediterranean. This part of North Africa here, pretty much all of Europe. Here's us here in the United States. United States and Canada here, like Argentina, Uruguay, Paraguay, parts of Chile here, parts of Southern Africa here. I believe this would be South Africa here, and probably South Africa, Eswatini, Mozambique. And then you see Southern and Eastern Australia and New Zealand are also this mild climate zone. All right, the Mediterranean climate, it's kind of similar to the temperate climates, but it's even more moderate. You have warm, dry summers and mild, wet winters. Almost all the precipitation in these areas occur during the winter. It's considered to be a subtropical climate zone, but it's kind of like really stable. Like if you see here, we have some Mediterranean climate on the west coast out in California. There's some of these areas, they enjoy temperatures in the 70s, degree range, almost year round, and it's very nice climate to reside in. And this kind of climate zone gets its name from the other area where it mostly exists, which is right here along the Mediterranean Sea. We also have some occurrence of this type of climate in South Australia as well. All right, continental climates. These are the ones that I was talking about. These are areas that are located away from large bodies of water, particularly the oceans. These kind of climates exist right in the middle of large continents. So right in the middle of North America, particularly in Canada, Right in the middle of Asia, areas like Siberia and Russia, or Mongolia is can be kind of. Mongolia is more considered like a arid, but parts of it can be kind of like these continental climates. What you experience here um, are really, really hot summers and really, really cold winters. I mean, vast differences in those seasons. And that's because they're located so far away from large bodies of water. They don't have that moderating effect of the ocean currents. So this just, there's a greater difference. There's a greater extreme between the winter conditions and the summer conditions. If you're interested in seeing what life is like in these type of areas, there's a great movie. I don't know if it's still on Netflix, but it's called Happy People, and it's a documentary on people living in Siberia. And you can see that they go through this. They go through extremely cold winters, and then they go through these really like nasty summers, and you wouldn't believe the mosquito situation in some of these areas. The people have to do things like harvest pine tar and use it to make a, bug repellent that they have to wear. It's amazing, but you want to talk about some tough people. The people that live in the centralmost parts of Asia, they are no joke, and they really do live in a pretty, harsh climate zone. All right, here, this map's not so good at showing where these areas are necessarily, but you can consider like areas like right in here, Central Asia. You see, you have this huge landmass. So when you're here in the middle, you're far away from the oceans and the moderating effects on climate. So like Central Asia in particular is affected by this continental climate. And like I was saying too, here in Canada, you got kind of the same thing. Maybe not as to the same extreme as, say, Siberia and Russia, but similar conditions exist there as well. All right, our polar or mountainous climates. All right, the polar climates are located north of the continental climates near the poles. So we're talking about like the Arctic Circle and the Antarctic Circle. These areas are known for constantly cold temperatures. I know we see that a lot of times they're covered in glaciers, and you see snow and ice in these areas, but these areas actually do not have a lot of precipitation. That's really old precipitation frozen there, and that's because the air there is really dry and cold. That cold air does not have a very large capacity for holding water, so the air masses there are typically very dry. Now, mountainous climates are somewhat similar to polar climates, but the reason why they're having those similar climate characteristics are not the same. Like with the poles, they're having those kind of climate characteristics because they're located at the poles. The sunlight they get is indirect and it's not very warm at all. Now, on the other hand, the mountainous climates, they're having these kind of conditions just because they're so high in elevation, like I was talking about earlier. So, examples of these polar mountainous climates are going to be your North and South Pole, the Andes Mountains, the Himalayas, these really high up mountain ranges. So, this map, it shows the polar and, the Arctic and Antarctic regions, but it doesn't show the mountainous regions. But we were talking about the Andes Mountains here along South America as being one of those areas. Some of those areas have those conditions, and then the Himalayas here across Asia have similar conditions, and probably also in the Ural Mountains, which kind of separate Europe and Asia around in this area here, or maybe a little further east if I have my geography correct.